Okay, this video is going to cover complex numbers. Basically, complex numbers look like a plus bi. This a is the real part of it, and the bi is the imaginary part of it. So like when I say a plus bi, that's kind of confusing. Imagine something like 5 plus 7i. The 5 would be the real part of it, and the 7i is the imaginary. And these are not like terms, so you cannot just combine them or something. All right, so let's look at some examples. Also, if you watch the previous video, I has a value equal to the square root of -1, which means I squared, if you were to square that, the root and the square would cancel and it would just leave -1. So I squared has a value of -1. Okay, root -9 plus 6, I'm right here. The root -9 part is the imaginary part. So if you think about root -9, if you watch the previous video, basically you just take an I out and it becomes a positive inside that root. And then you know root 9 is 3, so this is like 3i right there. So in terms of writing this as a complex number, the real part generally comes first, so that's the 6. And then I had 3i, so plus 3i. Okay, number 2, root -50. Again, you just kind of think about root -50, take the I out, and then it becomes root +50. And then you can break down this root. Root 50 is root 25 times root 2, which is 5 root 2. But don't forget, you had the letter I out in front that you took out. So this actually becomes 5i root 2. So if I had to write this as a complex number, the -11, the real part, would come first, and then positive 5i root 2 would come next. Okay, number 3, the root -27 part is the imaginary. So just call it I root positive 27, which breaks down to be root 9 times root 3, which is 3 root 3. But you had the I, so this is 3i root 3. That's the imaginary part. So my answer for number 3, the -8 is the real part. It goes first, and then plus 3i root 3, like that. All right, sometimes they'll just give you like a number or just an imaginary part of it. When this happens, you need to cover both the A and the B. So you got to figure out what they're giving you. In terms of number 4 here, they're giving me something with an I, which is the imaginary part. So the real part doesn't exist. You can just call this 0. This is 0 plus 7i. See, now I've got an A and a B, and I didn't actually change the value of anything. So same thing with number 15. With number 5. They gave me the number 15, which is like the A part of it. I still need the BI part of it. Well, there is nothing there, so we're just going to call it 0i. So this one would be 15 plus 0i. All right. Now, in terms of adding, subtracting, multiplying these things, you only combine the numbers with the numbers and the imaginary part with the imaginary part. So here's what I mean by this. 5 and -2 are like terms. They combine to be 3. 7i and 6i are like terms. They combine to be 13i. And that's it. That's all you have to do for those. Where they're going to try to trick you is they'll give you something where it's like a minus in the middle. This minus applies to both of the things in the parentheses afterwards. So if I were you, I would just rewrite this. 8 plus 3i. I would change that minus to a plus and distribute it into the binomial to the right of it, the 2 plus 4i. All it does is change the sign. So now it's -2 minus 4i. And then now it's just like the first one where I've got my like term, 8 minus 2 is 6. And then I've got my 3i and negative 4i. Those combine to be negative 1i or just negative I. Same thing. You could put a 1 there if you wanted. It doesn't matter. So that's what I would do on this next problem. I would distribute the negative right from the start and rewrite this problem as 6 plus 5i. Now, once you distribute, it's a plus in the middle, and it just changes the signs of everything after it. So now it's minus 10 and plus 8i, like that. And now I just combine like terms. 6 minus 10 is negative 4. And then 5i plus 8i is 13i. All right, where this gets a little bit tricky is when you have to multiply. So let me show you what's going to happen. In this problem, since there's nothing in between the 3i and the parentheses, that means it's a multiply right there. Basically, you're going to have to distribute this 3i to both things. So when this happens, you just multiply the numbers. So like negative 6 times 3 is negative 18. But don't forget, you had an I that you were distributing as well. So it's negative 18i. And then here's the tricky part. When you do this second distribution, this 3i times 9i, 3i times 9i is 27i squared. And I squared has a value of negative 1. You can basically substitute I squared. You can substitute this I squared right here for negative 1. So it's like it says 27 times negative 1, which is just negative 27. Once you get good at this, you can realize that from here to here, it's just a sign change on the number. If you see I squared, just go change the sign of the number and take away the I squared. See how it was positive 27? Now it becomes negative 27 and the I squared just disappears. That's what I'm trying to tell you right now. So when I distributed this 3i times 9i, 27i squared becomes minus 27. And then in terms of writing this as a plus bi, I'd probably change it around. I'd flip it. So I'd put the negative 27 first and then the minus 18i, like that. All right, now where they get a little more tricky is when you have to run FOIL, or the box method, in terms of multiplying a binomial times a binomial. So I'm going to run FOIL on this problem. FOIL is first, 2 times 5 is 10. Then it's outside, 2 times 3i is 6i. Then it's inside, negative 7i times 5 is negative 35i. And then it's last, negative 7i times 3i is negative 21i squared. All right, this negative 21i squared is just like what happened here. So basically, negative 21i squared. The I squared part becomes negative 1. So it's like it says negative 21 times negative 1, which is positive 21. So I could rewrite this problem as 10 plus 6i minus 35i, and then this part changed to be plus 21. Now you're going to have to combine like terms. These things with the i's are like terms, and then the numbers are like terms as well. So my answer here, 10 plus 21 is 31. 6i minus 35i is minus 29i, like that. So let's look at one more example of when that happens, because this is probably a common test question. So I'm going to again run FOIL. Anytime I see a binomial times a binomial, binomial times binomial, I'm going to run FOIL. So the first 2 times negative 3 is negative 6. The outside 2 times 4i is 8i. The inside 8 I times -3 is minus 24i. And then the last is 8i times 4i, which is 32i squared. This 32i squared, the I squared becomes -1. So this changes to be -32. So I can rewrite this problem, -6 plus 8i minus 24i. And then this part we just said became -32, so minus 32. Now just combine like terms. So I'm going to combine the -6 and the -32 first. That makes -38. And then I've got the 8i minus 24i is -16i, like that. All right, so the main takeaways from this, I squared has a value equal to -1. So there's going to be some situations when you multiply this out and you get something with an I squared. All you have to do is change I squared to be -1, and then just multiply whatever number was there by -1, and the i's go away, and you end up with just a number. Another takeaway is when you're combining these things, be sure that you only combine like terms. You don't combine something that's unlike terms. And then in terms of filling the A and the B spot, sometimes they'll give you both, and it's not that difficult. Sometimes they'll only give you one. When that happens, fill the other slot with a 0 or a 0i. So those are complex numbers. Hope this video helped.